Hey everyone, today we'll be doing another lead code problem. 88 merge sorted array. We have already done um, merge to sorted list. I don't know what was the problem number, but we have done a problem like this with list. So in this problem, let's read some description because this is pretty descriptive and we have to understand what's going on here. And you are given two integer arrays num1 and num2, two integer arrays sorted in non-descending order, which is ascending order, uh, and two integer and an m, which will be the number of elements present in num1 and num2 respectively. M1 will represent the number present in num1 and will represent the numbers present in nums2. Merge n m2 into a single array sorted in ascending order, non-descending order are the same. So, and furthermore, we have the final sorted array should not be returned by the function, but instead the array nums 1. To accommodate this, num1 has the length of n plus 1, where the first element denote the element should be merged as the last element has set to be 0 and should be ignored, and n2 has the value has the length of n. So what they are saying here is that we do not have to return and we do not have to make or return a separate array for this whole procedure. What we will be doing is just adding the numbers at in m2 in m1, because the number m, and they are saying that don't worry about this, we that and number nums1 have not enough say number 1 nums1, their names are so messed up, num1 and this and that. They should have named them better, like first array and second array. But either way, let's see where were we. They are basically saying that num1 can take the whole num2 in it. Okay, now let's see an example. So we are inputted this array. Its length is number of element, not length, number of elements. It has three. So, and this is also having three. And when we merge them, we should return, not return, but in place of one, we shall have an ascending sorted list, and this is how it works. So what we'll be doing here is just making a pointer which will point here, and we will start comparing. This 6 will be compared with this 3 if it is greater, because obviously this shall be the greater number in its own list, because this is in ascending order. If 6 is greater than 3, we will append 6 here, and then we will decrement n, and when we decrement n, we will be going at 5. 5 we will compare with 3, we will see that this 5 is greater than 3, we will append it here at this location, and we will again minus 1 with n, and now we will be appending, we will be comparing 2 with 3. But in this case, no, in this case we do not have uh, num2 digit as a greater, we have this as a greater 3. So we will be copying it to the last node, which will be and also I forgot to explain this. When the last pointer is here at the last location, whenever we do a loop, we will always be removing, we will always be negative 1, or it's subtracting 1 from the last, moving that pointer to null location, to a 0 location. So now we'll be comparing 3 with 2. 3 is greater, so we will copy it to the last, no, last position. Last is here, and now we'll be comparing 2 with uh, 2, and we will add here, because the last pointer is here, we will add 2 here, and that's how we sorted our whole list a whole array, and we will be having an edge case, but I will explain it later after writing some code. So I will make a variable named uh, and -1 because I have to use it in the indexes. So while uh, if I use it like this without -1, it will give an error index out of bound. And while m is greater and n is greater than 0, if we will be comparing this value with this value, so I'll be saying nums at m minus 1. If nums at m minus 1 is greater than nums at nums 1, their names are so difficult, like so confusing. Not difficult, confusing. uh, and if greater, what I said, we will be copying it to the last node. So I am again saying node. I have been doing a lot of node problems, but this is an index. So nums 1 last is equal to nums 1, and it was m minus 1, I think. I am getting confused out here. So after doing all of this, we will just add decrement m minus 1, and in the else case we will add n1 last with the nums to n minus 1, which will be just comparing like 3 with 6, something like this. Like 6 will be compared like with 3, and if it is smaller, then we will append simply. So now we will decrement in 1. Okay. And after doing one of these operation, we will just return just -1 the last, because obviously we are appending something at each step. We is filling something, so we will be decrementing our last. And after that, after all of this, we will see that I have to I will write some code, and then I will tell you what happened here. And nums at 1 last, and nums and n minus 1, n minus 1, and let me see if it works. I will explain these three line of codes in just a minute. Let me see if it runs or not, or we have an error. We do not have an error, but these three lines will do is, we were lucky in this case. We have one here, like a smaller number here. But if we get like this kind of list like this, and one will be in the second list. So what we will be doing, we know that n is greater than 1, but m is not greater than uh, uh, 0. N is greater than 0 and m is not greater than 0. So what will be the remaining portion, like whatever we have, like 1, anything less than 2 or whatever, it will generally be 1, because obviously to have 1 before it, because it is in at the ascending order. So whatever it is remaining at the very front, we will just append it to the last pointer, which will be at the very first. So this one will be going up here, and this is it. And this should look like this, and that's it.